You know that sound, right? Lub-dub, lub-dub. It's the rhythm of life itself, with us from the very beginning to the very end. But have you ever really stopped to think about what's going on in your chest during that one single beat? Well, that's what we're going to do. Let's follow the journey of a single heartbeat and see the incredible story that unfolds every single second. So, what is a heartbeat, really? It's so much more than just a simple squeeze. It's this breathtakingly precise performance, a perfectly timed dance between an electrical spark and a powerful mechanical pump, and it all happens in less than a second. In this explainer, we're going to trace that journey, right from the initial spark to that final push of blood. Okay, before we dive deep, let's just get our bearings. This is our engine. The heart is basically a muscular pump with 4 rooms, or chambers. You've got the 2 upper chambers, the atria. Think of them as the waiting rooms, and then you have the 2 lower chambers, the ventricles, which are the real power pumps. The entire point of this amazing machine is to move blood around, delivering all that good stuff like oxygen and nutrients to every single cell in your body. Now for Act 1 of our story, the electrical signal. Where does the command to beat even come from? Most of our muscles need a signal from the brain to do anything, but the heart is different. It has its own incredible built-in power source. This amazing property is called automaticity. It's pretty much what it sounds like. The heart's ability to generate its own electricity, to create its own rhythm, all by itself. It doesn't wait around for instructions from the brain. It is the instruction. It's got its own internal automatic pacemaker. And to give you an idea of just how powerful this is, the source material points out something pretty startling. Even if a heart is removed from the body, it will keep on beating for a little while all on its own. That's automaticity in action. It's an engine that can literally start itself. Okay, so where is this automatic spark coming from? It all starts in this tiny little cluster of special cells called the sinoatrial node, or for short, the SA node. It's tucked away in the upper right chamber, the right atrium, and this little thing is the boss. It's the heart's natural pacemaker, firing off electrical impulses at a steady pace of about 90 per minute, setting the tempo for the entire show. But that first spark from the SA node, that's just the beginning. For the heart to beat the way it's supposed to, that electrical signal has to spread through all 4 chambers in a really specific sequence. It's not like a flash of lightning hitting everything at once. It's much more like a perfectly choreographed electrical relay race. And that race happens on a special kind of racetrack. It's called the heart's conduction system, which is just a fancy way of saying it's a superhighway of specialized cells. They're all designed to carry that impulse from the starting line at the SA node all the way down through the heart, making sure every part gets the message at the exact right time. So here's the path. The race starts at the SA node, and the signal spreads across the atria, the top chambers, telling them to contract. Then the signal hits this critical checkpoint, the AV node. Here, it pauses, just for a moment. After that strategic delay, it zips down something called the bundle of His and through the Purkinje fibers, finally reaching the ventricles, those big, powerful lower chambers. Now this is where the design gets really, really smart. Not all parts of this racetrack have the same speed limit. At that AV node checkpoint, the signal slows down to a crawl, just 0.05 meters per second. Why? Well, it's genius. This pause gives the atria enough time to finish their squeeze and completely fill the ventricles down below. Then, once the ventricles are full, the signal hits those Purkinje fibers and floors it, accelerating to a blazing 4 meters per second. This ensures both ventricles contract at the exact same time for one big, powerful, unified pump. All right, the electrical relay race is over. The message has been delivered. Now for Act 2, the mechanical response. This is where the heart muscle takes that electrical message and turns it into the physical action of actually pumping blood. We call this whole mechanical sequence the cardiac cycle. You can think of it in 2 main stages. There's systole, that's the contraction, the squeezing part, and there's diastole, that's the relaxation, the refilling part. 1 squeeze, 1 refill. That's 1 heartbeat. And how long does this whole intricate cycle even take? Well, if you're just resting, with a heart rate of about 75 beats per minute, the whole thing is over in just 0.8 of a second. It's just an incredibly rapid and efficient process. Let's actually walk through that 0.8 seconds. First, the atria give a final little squeeze to top off the ventricles. Then, slam, all 4 heart valves shut, and the ventricles start to contract, building up a ton of pressure. That slamming sound? That's your first heart sound, lub. Once the pressure is high enough, the exit valves fly open and blood is powerfully ejected. After that, the exit valves slam shut again. That makes the second sound, dub, as the ventricles relax. And finally, the entrance valves open up and the ventricles just passively fill with blood, getting ready to do it all over again. This whole process, the electrical race followed by the mechanical squeeze, is just amazing. But how can we actually see it happening? I mean, how do doctors check if this perfectly timed dance is running the way it should? Well, they use a tool called an electrocardiogram, or ECG. By putting sensors on the skin, an ECG machine doesn't listen to the sounds or watch the squeeze. It's actually recording the electrical relay race itself. It gives you a visual printout of the heart's electrical story from start to finish. And this is the moment where it all comes together. On an ECG, that first little bump you see, the P wave, that shows the atria getting their electrical signal to fire. Then you see that big, sharp spike, the QRS complex. That's the powerful signal telling the ventricles to fire, which causes that lub sound. And that final bump, the T wave, shows the ventricles resetting themselves for the next beat. An ECG is basically a direct transcript of the electrical story we've been following. So why does all this matter so much? Well, because when any part of this incredibly precise sequence gets disrupted, whether it's the electricity or the mechanics, the heart can't pump as well as it should. And this can lead to very serious conditions like heart failure, where the body just isn't getting the oxygen-rich blood that it needs to survive. I mean, just think about that for a second. This whole complex cycle of sparks, delays, squeezes, and refills, it happens perfectly without you ever thinking about it about 100,000 times every single day. It's an endurance feat that's almost impossible to wrap your head around. From that self-starting spark to a perfectly synchronized pump, the journey of a single heartbeat is nothing short of a masterpiece of biological engineering. This little automatic system just runs and runs. It kind of makes you wonder, doesn't it? What's the most amazing automatic system that you can think of?